Hi everyone, welcome to part 5 of 6 of the 2015 Probability Methods exam rundown. Again, this is last year's paper. We're just going over this for revision. Question 3. When calves are born into a pedigree beef herd, decisions are made after they are 1 month old and again when they are 3 months old as to whether they will be kept in the herd or sold. 55% of calves are born male. At the age of 1 month, 70% of male and 20% of female calves are sold. Of the remainder, at age 3 months, 80% of males and 35% of females are also sold. Okay, there's two ways that we can put this information down. The easiest way I find would be to draw it as a probability tree. So let's do that. I will show you how to do the contingency table at the very end of the section. So we've got males, we've got 55%, so that's 0.55. Females, 0.45. The first event, okay, is shown by these branches, and they're born either male or female. That's the assumption. And when drawing the probability trees, remember that a set of branches, the branches that come out from the same point, have to equal 1. Okay, sorry about this. So we've got the next event is that they are either bought or sold. So if we say sold, got 70% of males are sold. So let's keep that consistent. Decimals, 0.7 are sold. 0.2 of females are sold. Okay, again, they're either sold or not sold. So how many are kept? They have to add to 1, 0.3. 20% of females are sold, 0.8 are not sold or kept. I'll just put K for kept. Okay, at the 3-month mark. Okay, once these ones are sold, they're gone. We don't need to worry about them anymore, okay? Kept. If we have kept and kept, sold and sold. Got males on top, so 80%, 0.8, 0.2, sold 0.35 are sold, which makes that 0.65, as 1 minus 0.35 is going to equal 0.65. Okay, now we can make our lives a little easier, and let's just find the probabilities or the proportions of these results here. Remember, if we're going along the branches, we've got to multiply. If we're going up and down along them this way, or across branches, we need to add them together. We've got 0.55 times 0.7. That's the 55% male and sold is, I might use a different colour so we can see this. 0.385 is that one. 0.2 times 0.45, 0.9, 0.9, sorry. That's a very small amount. Multiplying along these top set of branches every time. 0.55 times 0.3 times 0.2 gives us 0.033. 0.55 times 0.3 times 0.8. Whoops. Zero point 13344. You can round that if you want. 0.45 times 0.8 times 0.35. Oh, so I'm going all the way along the very bottom. Gives me 0.126. Now I'm going through this chain. So that means I've got to use these numbers. 0.45 times 0.8 times 0.65 gives us 0.234. So the beauty of the probability trees that I like is that it makes it very clear which numbers I need to be adding and multiplying, which I don't necessarily have when I've got a contingency table. However, when there's a contingency table, as you will see, it's a lot easier to just read numbers off it. So here it says, find the probability that a randomly chosen calf born into the herd will be male and sold. Okay. That's the multiplying. Male and sold, we've already done it when we put it in. So it's 0.385. If you want, you can write your working in and say 0.55 times 0.7 is equal to 0.385. Okay, if you don't write this working and you take it just off your table if you've done the working, that's fine. Makes it easier for you to check when you go back through your exam paper when you check. Sorry. If you didn't write all this working here during your exam, then I really do suggest showing your working. And that's so that when you go to check through your paper, you know exactly which numbers, and especially when it says and sold, you can double check your probability tree and see that sold is 0.7, where you might have accidentally done 0.3 before. Okay? I know I'm quite prone to doing stuff like that. Part 2, find the probability that a randomly chosen calf born into the herd will be female and sold at the age of 3 months. So female down here and sold not at 2 months but at 3 months. So it's gone through this chain. Sold. We can read it straight off our probability tree. If you haven't written this, then I really do suggest writing your numbers here. 0.126. What percentage of cows will eventually be kept in the pedigree herd? Okay, so we want the ones that are kept, which means, if I use a different colour pen again, we want these ones and these ones. Okay, so it can be female and kept or male and kept, so we need to add them together. Got 0.3033 plus 0.234. 0.267. I'm going to swap back to blue. That's the question done. In a particular year, 550 calves were born. How many males can be expected to be kept in the pedigree herd? Okay, well, we know the chances of them being male and kept after 3 months, which is 0.033. All we have to do here is multiply that together. 0.033 times 550 calves, which would give us 18.15. You don't have to round, given that you're not really penalised for it. However, I really do suggest saying it's going to be 18 calves. Or you could say approx, if that makes you feel better. Okay? The ratio of male to female calves being kept in the herd after 3 months is about 1 male to every 7 females. So 1 to 7, that's the ratio. This is to be changed to 1 male to every 10 females. If the number of male calves remains the same, what proportion of females would have been sold altogether? Okay, so the total proportion of females sold would end up being this one plus this one times, that's males. So we want females. And they're talking about wanting sold. So these proportions here change overall. Okay. They didn't ask us for what's at the 1 month and then the 3 month mark. They just want to know overall. Now remember, when we're moving down these branches, we're multiplying. So what they're actually wanting is something. So we've got the 45% females times something, let's call it P for proportion, is equal to the new amount here. Now back here, we know that they want to keep the proportion of males kept the same. We know that the proportion kept is 0.033, right? So if we've got 1 male to every 10 females, if this is 1 male, we have to multiply this by 10 to get the equivalent ratio for females. Why are we doing that? Because 10 times 1 gives us 10, which gives us our 10 females. So, if this is our new 1, the 0. I shouldn't put a dot up there. If this is our new 1, the 0.033, then we need to multiply this by 10 to make the ratio equivalent. Now we know that the number of females kept after 3 months is going to be 0.33. We want to know the proportion, the probability of them being kept. We need to know the probability of them being sold. So we've got 0, or the proportion, 0.45 is minus 0.33. So I'm just going to say sold female and sold. It's going to equal 0.12. 0.12. I didn't need my calculator for that. Or if you're going to work down the page, So going back to here, where we said that we're going to need to multiply by something to get 0.12. Got 0.45 times some kind of proportion is equal to 0.12. Now we can just use algebra and rearrange. If we multiplied p by 45, we need to divide it by 45, that whole lot, to get back to what p is. What we do to one side, we've got to do to the other, 0.45. You can leave it like that, or if you want to round it, or put it into decimals, we would get 0.26 recurring, which would mean you could round it, so that's 4 decimal places, 267 dp, or 0.27 to 2 dp if you want, and we are done. Cool. Thanks for watching. Ka kite.